So I'm here today with Juliet Houghland, who is a data scientist at Cloudera. Juliet, welcome to the Boston Data Festival.
Oh, thank you, Seamus. I'm really excited to be here.
Great to have you here. And so your talk title today is Best Practices for PySpark. Can you tell us a little bit about your talk?
Sure. So I spend a fair amount of time in my job talking with customers at Cloudera about what sort of problems they have and how they want to solve them. A lot of customers are very excited about Spark, and they're really excited about using Python and Spark. My general inclination is to use Scala to write Spark, but hearing this over and over again from customers, I realized I really needed to dig into how to best use Python and Spark together in CDH. And so I started making demos and building things for customers, helping them work through problems, and realized that even though the API docs in Spark present Python as just another alternative, there's a lot of special considerations that you need to think about when you're writing PySpark jobs. And so I decided it'd be useful for me to combine all of this information into a talk and go around talking to people about it.
Fantastic. So there's a lot of talk about Spark replacing Hadoop, but it's more of a question that Spark can be used alongside Hadoop. Can you tell us a little bit about the various use cases and how you use Spark in association with Hadoop?
Sure. So I think the premise of Spark replacing Hadoop is sort of a mix of two different roles. Spark is a data processing framework. Hadoop is an ecosystem that contains data storage, data processing, data movement, ingestion. And so there are many examples that I see of using Spark and Hadoop together. So from an analytic standpoint, the simplest one that I see is you have data in HBase, you have data in HDFS, or in Impala or Hive table. You ingest this data into Spark for a job, you do some analysis, you write out another large file or maybe results to HDFS or back to HBase. I've also seen almost every Spark streaming job that gets set up, people want once and only one semantics, and one of the best ways for us to guarantee that is to combine Spark streaming and Kafka. And so we'll often see Spark streaming and Kafka together. There's many different ways that these two things can be combined, but often, Spark you don't process data for no reason.
Yeah, exactly.
Spark ends up getting combined with lots of other things. I think people are just very excited about Spark, and it's like such a simple API. It's relatively easy to learn how to write the Spark jobs. That people want it to be the thing that just fixes how hard it is to deal with large amounts of data.
Absolutely.
It's not quite that.
Right. And I was reading the abstract for your, just getting back to your talk for a moment. You said you were going to address some common problems people have in Spark, such as serialization. Can you talk a little bit about some of these common problems?
Yeah. So I would say the two most common problems that I see, either from looking at JIRAs or email form lists, my own experience, has to do with serialization of Python and complex dependency management for Python packages.
Okay.
So in the serialization realm, you're working with a distributed system. You need to be able to take data that is loaded in Python, share it with a JVM, take it back to Python, apply a Python function that you defined on the driver node, ship that up to the cluster, apply that to data that's on the cluster. So this involves a lot of serialization, both of functions and of data. And people run into nasty problems with this all the time, that the errors show up in funny ways. Okay. So one of the things I'm going to talk about is how to serialize, or sort of keep an eye out for serialization problems before you actually run it on a cluster. And then the second thing that I see very commonly as an issue with PySpark jobs is that people are excited about using Python on a cluster, and one of the reasons is, of course, they already know Python as a language.
Exactly.
And the other is that they have all of these tools and libraries for numerical processing, like NumPy, SciPy, scikit-learn, pandas, stats models, and they want to use them. And so they'll write these jobs that depend on these modules, and suddenly they need these modules to be installed on a cluster, and they need to be able to manage these modules on a cluster. And then they have a teammate that needs a different version of that module.
Exactly. Yeah, it's quite complex.
Yeah, and so that is a problem that I think we're just beginning to address, but I have some solutions and suggestions for.
Oh, fantastic!
So we're talking about that.
Wonderful. And for those of our audience who are listening that are not going to make it here to the Boston Data Festival, we will be recording it and get the slides, and we'll get that online. So that looks like it's going to be a fantastic talk, which will be happening in about 20 minutes. Now, I was reading your bio earlier, and what struck me as interesting there, you've worked a lot on predictive maintenance models. Can you tell us a little bit about that?
Yeah. So prior to Cloudera, I worked at a company called Deep Signal, where I was the first employee engineer. We were trying to figure out how to best serve the oil and gas pipeline industry. So they have a ton of data that they collect, and they make consistent money on their pipelines. It's like a well-identified monopoly, basically, where they're allowed to hold these things as long as and they know how much like oil and gas will be flowing through, and they have a huge maintenance budget, and their primary goal is not to stimulate more oil and gas, exactly how much they can use or how much they can hold, but to make sure that they don't have any what they call releases. And so this is when you have a pretty violent, vigorous release of oil and gas into the environment. So they have a ton of historical data about their original pipeline diameters, the coatings, the soil around the pipelines. And then they also have these things called pigs, which are robots that are instrumented with sensors that can measure things like the capacitance as it travels, and then from that infer wall thickness. So they send these pigs through the pipelines every few years, and they update this data, but the way that they make decisions about pipeline maintenance currently is not particularly data-driven, though this data all exists.
Right.
And so our company went around, got organizations involved in this, started collecting data, started standardizing, normalizing their data so we can use it across many companies.
Oh, great.
And then started building hazard models or survival models, survival analysis sort of things. So
very interesting.
We could segment pipelines by soil type and coating type, and then look and build empirical models for how long these pipeline segments would survive given their coating, the current corrosion, and so
definitely
help them identify which segments of pipeline need maintenance immediately.
Yeah, sounds like a well-needed application of data science, and sounds like a fascinating talk maybe for the future in and of itself. So Juliet, thank you so much for stopping by. Thank you for being one of our speakers, and actually you are speaking at ODSC West coming up in San Francisco in mid-November, so delighted to have you both here, and delighted to have you in San Francisco in the future. Thank you so much.
Thank you so much. I'm excited to be here.
Excellent.